Hello everyone, I'm Giuseppe Maggiore, and in this lesson we're going to dive into some practical exercises for the course Introduction to TypeScript. The structure of this practicum is going to be quite simple. I'm going to show the text of an exercise. Usually the exercises are quite simple, but they can also be a bit more articulated. Then I advise you, put the video in pause, try to do the exercise yourself, and then look at how I would do the exercise. Let's start. Now, the first exercise is quite simple. Define one variable for each primitive type, number, boolean, string, and begin. Reassign a new value to each variable. Okay, so let's start with an n, with a number. I'm going to declare the type immediately, but it's not strictly needed. I can say n colon number is equal to 10, but I could also say n is equal to 10, and then TypeScript would infer n to be a number. Let's define the boolean. Let's have a string. And finally, let's get the begin. I'm going to state that this is a begin. Yes, because I want to make sure that I'm getting the right constant without errors, and indeed now I can just remove the type annotation. Okay, now I can reassign a new value. There are many ways to assign a new value. I could say, for example, that n is incremented by 1. I could say that the boolean is flipped. And I could add another, I could replace the exclamation mark with a question mark in hello world, and finally I could negate the begin. Let's print these values in order to see what their final, let's print these variables so that we can see what their final value becomes. We print n, we print b, we print s, and finally we print bi in order to make sure that we have seen the assignment take place. So we expect 11, false, hello world followed by 3 question marks, and minus 100. 11, false, hello world with, just 1 question mark and minus 100. Let's take a look at the definition of replace. So replace replaces a string with a replacer, yes. Okay, so clearly this only replaces the first instance. Okay, well, interesting. And fair enough, it makes sense. Alright, so that would be the first exercise. Let's move on to the second exercise. Now, the second exercise asks us to define one constant for each primitive type. Try to reassign a new value to the constants. So, the constants are defined with const instead of let. Const 10, and that would be n. True, and that would be b. The string will be again hello world. And the begin will be again 100. As soon as we try to change a constant, then we get immediately a compiler error that says cannot assign to n because it is a constant. Now n++ is a statement which is a shorthand for n is n plus 1, and indeed, as you can see, it's an assignment, and as such it's not allowed. The same applies to every single other attempt we might want to make at reassigning a constant. Also here, same error, cannot assign to b because it is a constant, and so on. This was a simple exercise, admittedly. Now, create a new scope with curly brackets and shadow the constants you defined with new constants with different types. Okay, so we have these constants and we cannot really reassign them. But what happens if we define n to be, well, we need to define them with different types. So let's say that they sort of rotate. Okay, so n will be minus bi. B will be n plus 1. Oh, no, it doesn't work because I've already overshadowed. I've already shadowed n. Let me think. Nah, okay. So, new constants of different types. Well, minus bi is allowed, yes, well, why not? B is going to be as dot replace and then exclamation mark with question mark. Then s will be, okay, minus 100n. Oh, this is interesting. This is accidentally interesting. So let's discuss this. And bi is false. Okay. Now there is some confusion now that's being caused by the overlap, because in the scope in the scope here, by trying to access bi, then TypeScript now gives precedent to the bi defined in this scope and says, yes, but you cannot use that bi because n precedes the declaration of bi. So it's not being super smart, because one might say, okay, you should use this value here, this constant that's defined in the parent scope, but because of an accident in how JavaScript was defined, where you could read variables in the scope, before having initialized them properly, now TypeScript has kept this behavior, and we get this slightly funky result. So let's put the constants, because if in this scope we want to redefine one of the constants that are defined in the parent scope, then we cannot use the constant defined in the parent scope anymore, because TypeScript will not allow it. It will give precedent to the constant defined in this inner scope. Okay. So n is now a big int, b is a word with one question mark and two exclamation marks, s will be 11, and bi is false. And now things work. Okay, let's print n, b, s, and bi. And let's do it twice. And as you can see, we get, in the first case, minus 100n, hello world question mark 11 and false. So that would be the big int, the string, the regular number, and the boolean. But here we go back to the constants of the main scope and we get 10 true hello world and 100n. For an easy exercise, there was some interesting insight to be gained here. Okay, now we get one node. Okay, and then the first exercise. Okay, now, so in order to read input, first install yarn add readline -sync. Okay, well, I think it was installed already, but now we are 100% certain. And then const question is require readline sync.question as string goes into string. Okay, so this is basically defining a function question that shows a prompt to the user and returns a string after the user has typed it. Useful for getting input. Okay. Calculate the average of 3 numbers you read as input. Okay, const number 1 is question of what is the first number, and 2, and then n3, what is the second number, and what is the third number. Let's print the inputs, n1, n2, and n3. It's always good to add some little tests to our program as we experiment with its components, so that we are certain that, that the components are doing what they are supposed to be doing. Oh, no. What is the first number? 10. What is the second number? 3. What is the third number? 4. Okay, and then we get 10, 3, and 4. Okay, makes sense. But what are n1, n2, and n3? They are strings. Okay. Now I'm going to do something that is not really super safe. I'm going to parse. I'm going to parse the int. But what is the danger here? Now, well, first of all, why are we doing this? Because parse int takes as input a string and returns the corresponding number. But yeah, what does it do if it's not a valid string, a valid number? Well, but first of all, let's see what happens if we put 10, 3, and 4. What is printed now is 10, 3, and 4. But these are numbers. These are not strings anymore. So that's good. Okay, so now we can process them. But what would happen if we said A, B, and C? Then we get not a number. That's quite ugly. But okay. So one should check for not a number in order to validate the input. That's not required by the exercise, and that's maybe a little bit too far for this. But yeah, you might want to do it in a real life scenario. Okay. The result will be now the average is the sum of n1 plus n2 plus n3 divided by 3. And now we can try to format a nice message like the average. So average of n1, n2, and n3 is equal to result. So 10, 3, 4, and the average would be 5.7. Okay, so 10 plus 3 plus 4 would be 17, and indeed the average is going to be between 5 and 6, okay, yeah, and closer to 6. Makes perfect sense. Okay, very good. Now, well, let's do them one by one. Given two numbers, x and y, input by the user, calculate how many times x can be divided by y with a loop. Oh, this is interesting. Okay, so for example, if we were to do this, so if we had, say, 32 and 2 as inputs, then you could say, okay, 32 divided by 3, okay, let's do, okay, let me simplify my life. 16 divided 16 and 2, then we could do 16 divided by 2, and this is equal to 8, so that's 1. 8 divided by 2, and this is equal to 4. 4 divided by 2, and this is equal to 2, and 2 divided by 2, and this is equal to 1, and here we stop because now we have a result which is smaller than 2, and so we cannot divide anymore. Okay, so x and y. Okay, what is the base, and what is the divider? Let's call it divider. Okay, so counter, because we're going to count. Okay, so the counter starts at 0, while x, we're going to divide into x, so we're going to forget the value of x every time. So while x is greater or equal than y, then y fits at least once into y fits at least once into x. Then we say that x is equal to x divided by y. Oh, and of course these are not constants because they need to change. Well, at least x, not y. And we increment the counter. Oh, why did I declare it as a constant? Okay, anyway. And then we can print, oh, okay, now this is a little unfortunate, so because I also want to print the original value. So original x is x, so I want to preserve it. Okay, very good. Otherwise I cannot print that y divides original x counter times. Now let's print the base. 16, the divider is 2, and 2 divides 16 4 times. 32, 2 divides 32 5 times. Okay, 33 and 2 divides 33 still 5 times. Okay, very good. This is very similar to what the logarithm function does. The logarithm function calculates, well, calculates, for example, log 2 in our case, how many times 2 would divide a given number x. And given the various logarithms, logarithm of base e, logarithm of base 2, so the natural logarithm, etc., you can calculate the logarithm in any other base. Okay. Now, what we could also do is turn this program into a program that runs basically forever. This can be handy in order to be able to test our little program on different inputs without having to launch it again. So let's have a do while. Let's also get as input an answer. So continue will be yes. Okay, quit will be no, while quit is not yes. And then we can say that quit is the answer to the question quit, yes / no. Okay. Now we can test a little bit better. Let me turn off full screen, because otherwise we have the little white bar of the iPad conveniently hiding the last line. Okay, so let's see, we have 1 and 2. Okay, 2 divides 1 0 times. Okay, makes perfect sense. Quit? No. The base will be 2 and the divider is 2. 2 divides 2 1 times. Okay, also correct. Don't quit yet. Base will be 4, divider is 2. 2 divides 4 2 times. Also correct. Now 64 and 2. 2 divides 64 6 times. Okay, quit? Yes, because I think it's enough for this exercise. All right. Now, given two numbers x and y input by the user, calculate the remainder of the division of x by y. Again, let's read the numbers. Parse int, question, what is the dividend, and what is the divisor. I haven't really attended elementary school in an English-speaking country, so I'm trying to remember from bits and pieces of information what the names are of these operators. I think it's dividend and divisor, but I'm also sort of guessing from my school, my school child past. Okay, anyway, there is one very simple way of doing this, of course, and we're going to do this twice. First, we're going to just use the modulus operator. Which is a percent sign. So what is the dividend? 7 divided by 3, and well, the modulus is 1. Okay, well, not very exciting. Okay, we want to know the remainder of the division. We can also do the following. While x is greater equal than y, it's the very same principle actually as the previous assignment. We can say x is x minus y, and then we count. We start at 0, of course. Oh, counter, and here we can just increment the counter. Let's see if I got it right. So 6 divided by 2. Oh, we also need to store the original value. original x is x because we're destructively destroying, we're destructively updating x. I don't know if you would maybe prefer to say temp is x and then here use temp, but then it's not a constant anymore, and we could declare these two as constants. This might be a little bit more elegant. Okay, so the dividend is going to be 6, the divisor is going to be 2, 6 modulus 2 is... Oh, of course not counter, we don't really care about the counter, just temp, because whatever remains in temp is the result of the last, so counter is simply calculating the division. Well, let's keep it, why not? But what we do need here is temp, because by decreasing temp by y every time, then, well, when we stop, then it means that temp is smaller than y, and that's the remainder. So let me show you the process. Maybe this will help. So let's say that we have 6 and 3, 6 and 2. No, better yet, 7 and 2. That's 7 remainder. Okay, so we do 7 minus 2, and that's 5. We do 5 minus 2, and that's 3. Then we do 3 minus 2, and that's 1. Now 1 is not greater or equal than 2, so we stop, and that is indeed the remainder. So let's say 7, 2, and 7 modulus 2 is equal to 1. Obviously, just using the modulus operator is a lot faster, so there's no reason to do this. This is just a way to exercise a while loop once more. Okay. Calculate the biggest of 3 numbers you read as input. Okay. First number, what is the second number, and what is the third number? Okay, how do we do this? We're going to do this with conditionals, with if then else. So, if x is greater than y, now x is greater than y, what is x actually also greater than z? So if x is greater than z, well, it sure does look like a z, but it's really not the same character, okay? Then, well, console.log x is the greatest. Okay, or now let's say max of x, y, and z is x. Okay, very good. Otherwise, now in this case, x is greater than y, but it's not greater than z. So z is the biggest. Otherwise, okay, x is not greater than y, so y is the candidate for being the biggest. So now we check if y is bigger than x, but it's also bigger than z. If that's the case, then the biggest of all is y. Otherwise, in here, well, y is bigger than x, but z is bigger, is greater or equal than x than y, so z is the big winner. Okay, now this is a little bit of complicated, I don't know, but it's a bit of an articulated piece of logic, so I really want to be able to test it many times quickly. Making it possible for us to test things quickly is never a waste of time, never. So you might think like spending some time in setting up your, let's call it your testing framework, distracts you from actually building your logic. Nothing could be further from the truth. Okay, so now we have our little testing framework. Let's run this. Okay, first number 3, 2, 1, and we get 3. Okay, so the system is capable of picking x. Now we want to get every one of the cases. Okay, so this was clearly this case. We've tested this. Now we want to pick this. So x has to be greater than 1, but smaller than z. Okay, so 3. Oh, what have I done? Oh, well, okay. you know what, yq is not equal to y, so unless we type y, we don't want the program to quit. Okay, first number 3, second number 2, third number 4. So we're going to enter here on line 15. And indeed we get 4. Okay, very good. Now, let's not quit. Oh, how silly. Well, my testing framework isn't really doing me a lot of good, because we need to read the input every time. Otherwise, what's the point? We can recompute the whole thing all over again. Okay, now 3. Now we want to test this. Okay, so let's think about it. Okay, so x has to be smaller or equal than y, but y has to be greater than z. Okay, so 1, that would be x. Now we need y bigger than x. And now we need a z which is smaller than y. And indeed, we get 3. Okay, very good. And finally, don't quit. Okay, this is the only time where when this rapid testing framework I built has actually been of any use. That's a bit ironic. Okay, now we need x to be smaller than y, so 1 and 2, and z to be bigger than y, and again we get 3. And now it's time to close this exercise. Very good. Now, okay, show a message saying that the user may buy alcohol only if their age, which is input, is at least 18, or they are accompanied by a person who is at least 18. Read the accompanying people, plural, with a loop as input. Oh, so this is complicated. So this means that we are getting one user and then a series of people accompanying them, and those people are read with a loop. Ooh, okay. So let's also leave this loop because we want to be able to test this program again. Now, const age. What is the age of the user? Okay. Now, if the age is greater or equal than 18, we can simply say, okay, the user may buy alcohol. I'm not condoning people buying alcohol, especially at a young age. I'm actually not taking a stance on this. I'm just computing a program that might help a cashier at a nocturnal shop, for example, decide whether or not they are allowed to sell alcohol. So this is not a moral exercise. It's just a technical one. Okay. Otherwise, well, we read the ages of the accompanying people. How do we do this? Well, const is someone accompanying over 18. Well, let's start by false because we don't know yet, and it's not a const, okay, because we are going to have to read them and to change this. Okay, so do is someone accompanying over 18 now is going to be, first we ask the question, what is the age of the next person in the group? And well, this is an int, we have to parse it, and then we check if this is greater or equal than 18. Well, then we are going to put true in is someone accompanying over 18, and now we simply stop reading. Let's be careful though, because well, there might not be another person in the group, so let's ask the question again. of whether or not there is another person in the group. Is there another person in the group? And this will be a yes or no question. And if the answer is no, then we use the statement break, which jumps out of this do while. Instead of using break, we could also have another variable that behaves like the Q variable. Well, up to you. Break can be handy in order to early force the termination of a loop, but it can also make it very difficult to read and understand a loop. So use it with caution. Okay. So what is the age of the user? 19. Okay, the user may buy alcohol. Quit? No, not yet. What is the age of the user? 17. Okay, is there another person in the group? No. Okay. Oh, well, maybe at this point it's a good idea to check if is someone accompanying over 18. Then we can print, well, actually, just let me copy, and otherwise the user may not buy alcohol. Okay, now this should cover all the scenarios. And now we are also getting a message. Okay, so 17, is there another person in the group? No. Oh, the user may not buy alcohol. Quit? No. Let's try again. What is the age of the user? 17. Is there another person in the group? Yes. What is the age of the next person in the group? 13. Oh, well. Okay. Oh. Well, okay, this is a mistake. So the loop quit too early, so I'm going to add here the exclamation mark because I do want the loop to continue until either break is hit, so we are told that there is no other person in the group, or we finally hit someone who is 18. But, well, then we want the loop to continue while we haven't found yet someone who is over 18. Okay, let's try again. What is the age of the user? 17. Is there another person in the group? Yes. What is the age of the next person in the group? 13. Ah, okay, so this one doesn't count. Is there another person in the group? Yes. What is the age of the next person in the group? 25. The user may buy alcohol. Then we don't need to ask anymore. Okay, well, this looks like it's working. I'm also not going to edit the videos or not show the bits where I make mistakes because I think it's actually quite useful to show, well, that mistakes happen and how you actually incrementally go about fixing them. So, yeah. Okay, now. This one is fun. FizzBuzz is an exercise that is shown, that is found very often in one or another variation in interviews, in coding interviews. If you're applying for a job, it could very often, it will happen very often that you are confronted with some very easy exercise like this one in order to just assess basic programming skills. Even in my own work, when doing recruitment, I've been using variations of FizzBuzz to screen out candidates who cannot program, because this is something that's it's quite easy to do if you can program, and impossible if you don't really have your understanding of programming neatly in order. Okay, so for each number up until n, which is input by the user, print on the console A if the number can be divided by 5, B if the number can be divided by 3, and C if the number can be divided by both 5 and 3. And we want to do this with a for and a while loop. Okay, so let's get n, and let's go through all the values up until n. Okay, so you might be tempted to do this in the order in which the statements are in which the conditions are expressed in the exercise, but that's a bit of the trick, because if we say if I modulus 5 is equal to 0, which is the number is divisible by 5, and you say a, then well, let's finish the naive version, which, let me warn you, doesn't work. Okay, almost there. So, and then if I modulus 5 is equal to 0 and I modulus 3 is equal to 0, then we print C. You can even try this. Oh, something went wrong in the process of compilation. No problem. Ah, no, nothing went wrong. I just need to change the prompt. What is the input number? Yes. Okay. So what is the input number? Let's say 15, or well, okay. Which numbers do we have that are divisible by 3 and 5? Because we want some of those as well. Let's say 16. So we get 15 included. Well, but 15 is divisible by both 5 and 3. But we're only seeing A's and B's. We're not seeing any C's, so this is bad. Why is it not happening? Because this condition here, I modulus 5, and this condition here are going to be triggered before this is even tested. So this condition, because if a number, let's say I is 15, okay? 15 is divisible by 5 and 3 at the same time. But 15 is also divisible by 5 separately. So this is true, and that's it. So either we add I modulus 5 is equal to 0 and I modulus 3 is not equal to 0, and here we would have I modulus 5 is not equal to 0 and I modulus 3 is 0, which, to be honest, is not even that ugly. Let's say we put 16, and then we get, okay, C for 0, because 0 is divisible by both 5 and 3, and 15. That's the last one, because that's divisible by both. Is it 15? 3, 6? Huh? Okay, I'm a little bit surprised now, because I would expect more values. Let's find out what's happening. Oh, no, of course, no, it's correct, because we're not really printing anything for the numbers that are divisible by neither 5 nor 3, which is correct. The exercise does not specify anything, so we're not really doing anything. Okay, let's print the original number then. So for I, here we have A, here we have B, and here we have C. Okay, what is the input number? 16. Okay, so for 0 we have C, 3 is divisible by 3, 5 is divisible by A, 6 is divisible by B, by 3, 9 is divisible by 3, 10 is divisible by 5, 12 is divisible by 3, and 15 is divisible by both. Okay, very good. Quit? Yes, I would say that's enough. So we wanted to do this with a for and a while loop. Okay, well, not very exciting, to be honest. So while I is smaller than n, and then we put the increment statement at the end. Okay, well, very good. We are going to test because we're good Boy Scouts. Okay, well, we do get the very same results. Quit, no, let's try it again with 5. Okay, quit, no, let's put 6, and so on. Now, one question might be, what do we mean with until n? Do we mean that the value is supposed to be included? I think it makes sense, and you might also make the stylistic call of saying, okay, we start from 1 because 0 is, that doesn't really say much. I don't know, up to you. So let's say that if we put 5, we want to get until 5, and we're skipping 0, which doesn't really, which doesn't really add much to our coding scenario. Now it's time to do a little bit of string matching. The next exercises require us to find the matches of one string inside another string. Again, we're not going to use function libraries because using function libraries is mostly just a matter of Googling things or going through the documentation. And for those things, you know, well, Google, ChatGPT, Copilot are actually excellent. But what we want to do today is obviously exercise our ability to problem solve with code, and so we use relatively simple scenarios, and these simple scenarios are very often also already solved in libraries. So no harm done. Anyway, define a loop to find all exact matches of a string inside another string. Let's start by defining a string, the source string, and well, okay, hello world. So there are many things we can do with a string, but one of the most interesting is that we can actually get the characters of a string with the square brackets. So the first character will be a capital H. Look at this. Then the second character will be a small letter E, and so on. We can also get the length of the string by calling source.length. And there you go, 12 characters, meaning that the last one we can read is the character at index 11, because we started with 0. Okay, what happens if we try to read past the end of the string? We just get undefined. There are no characters after the character at index 11. So this number that we put between the square brackets is the index. Okay, now, as we already know, it's slightly better to get to the question from the input. What is the input string? And then the search string is what is the search string. And now all exact matches. Okay, very good. So how do we find the matches? Well, the matches are simply found going through all the characters one by one of search inside the source. So let's go through all the characters of source, because every character in source might be the starting point for one match. So for let I is equal 0, I smaller than source dot length, and obviously we increment I by 1, and now we have to see if starting from source of 0, a source of I and search of 0, because the one we're searching always starts from 0, but the source string we're looking into starts at I. Well, how do we do this? We actually need a while loop, might even be better. Okay, so let's start with j. J is 0, and this j will be the index in the search string. Now, the basic will be that we check while j is smaller than search.length, because obviously we're going to search through to iterate through all the characters of the search string, and here we have to increment j explicitly, but also we continue while both search j is smaller than search.length, but also search of j, so the current character, is equal to source of I. I'm putting this check j smaller than search.length because I want first to check that j is smaller than search of length, so j is a valid character in search, and then I'm going to access search of j. I don't want to do it the other way around, because the other way around might perform checks that are past the end of the search string, and that is bad. JavaScript is kind of forgiving, and TypeScript as well, of course, because it just gives undefined back, but there are many programming languages where the normal behavior of the language to your attempt to read past the end of a string simply produces a runtime error that stops your program. So better to perform this check first, because if this is false, then the end will not evaluate this bit of code. It will just not run at all. So it's a bit safer and a bit cleaner. So now what are we doing? We're saying, okay, we increment j by 1 only if the current character, so source of I, because that is the I represents the start of the sliding window, but we're not done yet. And search of j. But obviously here we're always comparing the same character of source but the character we want to compare search of j with is, well, if j is 0, that's the first character starting from source of I. If j is 1, well, that's the second character starting from source of I. If j is 2, then it's the third character starting from source of I. Meaning that here we are moving our sliding window starting from I and moving it together with j. At this point here, the while loop has been interrupted. And it has been interrupted for one of two reasons. Either we got to the end of the search string, in that case, we're done, and we have a match, or it was interrupted before the end of the search string. Look at this. If j is smaller or greater or equal than search.length, it means that the while loop terminated because this condition became false. So all the characters up to the last one were equal in the subset starting from I in the source. So here we can say console.log, we have a match starting from string interpolation. Actually, I should just get the habit of always using string interpolation, because worst case I don't have anything to interpolate, but okay. Anyway, starting from I. Okay, let's try this. Now, what is the input string? Let's say ABC, DEF, ABC, XYZ. And what is the search string? Let's say ABC. And we have two matches starting from 0. That will be this one, ABC, and then 0, 1, 2, 3, 4, 5, 6, 7, 8. Very good. We have both matches. Let's try partial matches. ABC, oh, pardon. ABC, DEF, ABC, DEF, AB. And now we're looking for ABC. And now we have only two matches. Makes perfect sense. Okay, well, this went smoother than I expected. Now, oh, now, so now we are required to find all prefix matches of a string inside another string. So all the matches where at least a prefix of search is found in input. And we're also going to decide that a prefix has to be at least 2 characters long, otherwise, just one character prefixes are not very exciting. Now the code is going to be the same, but in this case, in order to find a prefix match, we don't need the whole string to match, but at least 2 characters. So what we're going to say is that if j is at least greater than 2, so the matches have happened for j equals 0 and j equals 1, then we have a prefix match. Actually, if we want, given that we care about prefix matches, but so if j is greater or equal than search.length, we're done. But if j is greater or equal than 2, then we have a prefix match, and here we have a full match, and now we're even giving a slightly better messages. Okay, now ABC, DEF, ABC, DEF, AB. And now we're going to search ABC, and we have, look, one full match starting from 0, one full match starting from 6, and a prefix match starting from 12. Okay. Now, we are now asked to find all the suffix matches. Okay, so a suffix match means that we want to find a search string where the end of the search string, the suffix, matches a piece of the source string. Okay, so in order to do this, we're going to scan. This is difficult. This I will get wrong many times. We're going to scan the source string backwards. So I'm going to scan it from, well, pardon, I'm going to scan it Now, we're going to scan the search string backwards, but we're going to scan the source string, skipping the first length of the search string. And then because the match happens backwards, it makes no sense to start at index 0. Okay, so let's say we're searching for, we have ABC, DEF, ABC, okay, and we're searching for BC, okay. Now, what are we going to do? We start directly from, well, this is length 2, so we start here. We don't start at index 0, we start at index 1, because the first match would still require us to have at least 2 characters to look into. So I will start, so this will be the value of I, and well, obviously the value of j will start from, will clearly start from also the end of the string and move backwards together. Okay, so I starts at search dot length minus 1, because we want to start at the end of the first block, which is long enough for source to still have enough characters before this block to potentially match the whole search string. Okay, then does j start at 0? No, j does not start at 0. J also starts at search.length minus 1. So j also starts at the end of the string. All right. Now, in this case, no, let's actually, you know what? Yes. Okay, so if we start at search.length, then we're going to decrement j, and we're not going to go further than j greater or equal 0, because we're going towards the beginning of the search string. Okay, then search of j is, we start with the last character, then the character before that, then the character before that, and so on until the first character of search. Very good. But then, what about source of I plus j? Because now I starts from the end of the character. Starts from, so I represents the end of the string we're trying to match. So if I is already 2 and j is already 2, we don't want to go to j plus 2, you know? Okay. So we're going to take I, and we're going to, so I is fine, that's the end of the string, the substring we're trying to match, but we're going to take j, and when j represents the end of the search string, we want it to also represent the end of this block. So we take search dot length minus j minus 1, let me think. Because when we start this process, we want, when we start this process, j is equal to search.length minus 1. So this is going to be search.length minus 1 minus j. So when j is at, okay, so let's look at this. And actually, you know, in these cases, it also might make sense to search, to simply print what are we comparing. So we are now comparing source of, well, let's copy this big expression, and search of j. Now in this case, if j is greater or is smaller than 0, then it means that, well, that's it. We checked even the last, the first character and of search, and we had, so we had a full match, just right to left instead of left to right. And if j, okay, is smaller than the end of the search string, minus 2, then we have a suffix match. I'm wondering why it would be. This is a very strange error. Oh, okay. Just the spaces were needed. Okay. Now let's try to run this. So let's say we have A B C D E F A B C, and we're looking for BC. Okay. And this is clearly not working. So something is going wrong. Something is going wrong with search. Okay, so well, it starts by saying it's comparing C and C, so it started somewhere reasonable. But now we have to find out something about this sequence. Let's remove the bit with the actual string comparison, and let's start testing our hypothesis. This exercise is also particularly tricky. You've seen how easily I've done the other exercises, because here we have to perform checks with very tricky indices. This is very unintuitive also, even for someone who has done this for almost 2.5 decades now. And the reason why I put this exercise is really to show you how, first of all, how hard this is for me, because the other exercises do kind of give a false sense of how hard these things actually are if you're not an expert. And also to show you a little bit how you debug something like this. So now I simply have to, see what would happen by scanning the search string right to left, but also the source string right to left. Okay, so we have the j index, and then we have this I plus search.length -1 minus j. Let's find out again. So let's say the input string is ABC, DEF, ABC, and the search string is BC. Well, not that it matters that much. Okay, so now stuff is happening. Plenty of stuff is happening. Oh, of course, I think it's all full matches. Let's see though. Okay, now we can see that on, I'm going to do this even better actually. I'm going to put a tab here. I'm going to note down, then this is j, and this is I plus search.length -1 minus j. Then we even get, a sort of little table. Okay, so let's look at this. Now, as you can see, j always goes down. So 1, 0, oh, well, we can clearly see that this I plus search.length minus I minus j is doing something funky, because, well, if j is decreasing, oh, so I would have expected so if j is decreasing, I'm also expecting this to be decreasing, because we're supposed to scan I right to left. Okay. Oh my god, I might have made this so much more complicated than needed. This is just, no, this isn't I minus j. Now, let's think about this. So when j is 1, we also want to have here I1. And when j is 0, we also want to have 0 here. We also want to have 0 because we're going backwards, and in the next iteration you actually see the same problem. So again, we're scanning the string search right to left, but we're scanning a subset, or a subsequence, I should say rather, of the source string left to right. Okay, so if j is decreasing, I minus j is going to be increasing. That makes perfect sense. Okay. As we continue to try to get our bearings, let's now try with j versus I plus j. And okay, so ABC, DEF, ABC, and we're looking for BC. Okay. Now, at least, I see decreasing sequences. Okay, so we have 1 and 0. Okay, then we want it to start from string, from character 1 in the search string, but we're starting from 2. But at least we're decreasing. So the first round should be 1, 0 on the J column and 1, 0 on the other column. Actually, I also find this debugging a bit ugly. So let's say that this is search and this is source because the expression is now changing. Okay, so in this case 1 0 2 1 here, well, obviously still 1 0 1 0, so the J column is correct, but this other column 2 1, it should be 1 0 3 2 should be then 2 1 and so on. So we're very close. Let's try again. A B C D E F A B C and B C. Okay, so let's see, 1 0 is compared to 1 0, then 1 0 is compared to 2 and 1, so that's shifted by 1, 1 0 3 2, and so on until, well, we get to the last character, 8 7. Okay, that's interesting. So 8 1 2 3 4 5 6 7 8 9, so 8 would indeed be the legitimate last character. Okay, well, this was a lot easier than I was thinking. So I made my life a lot more complicated with this big formula. But human intuition does have the tendency to fail when doing these things. Okay, let's try again. Okay. Oh, that's interesting. So, oh, pardon. We don't need this bit of useless debugging string. So A B C D E F A B C, and we're searching for B C. Okay, let's see. We have a full match starting from 2. Okay, that's very good, because that is BC, so starting from 2, and then so 0, 1, 2, and then backwards, because we're looking for a prefix, so also the bit of information we're getting is good. Then starting from 8, which is the last C, and that's also a full match. Okay, now let's try something else. ABC D, X, Y, Z, A, B, C, D, and we're going to look for BCD. Also working, full match starting from 2, and a full match starting from 9. 0, 1, 2. I'm wondering why it would say starting from 2, but the one starting from 9 makes perfect sense. But I wanted to test something else. A, B, C, D, X, Y, Z, and then just CD. I'm looking for BCD, and okay, we only have a full match starting from 2. So, well, oh, but fortunately, this check doesn't make sense, but we're not supposed to find the partial suffix matches, because that would be a nightmare. Okay, I think the system is working decently. I'm still wondering though, why is this saying that the full match is starting from 2? So let's think about it. So 0, 1, 2. I'm looking for BCD. No, I would really expect this for this to be 3. So let's try this again. So we have ABCD, XYZ, ABCD, and we're looking for BCD. So the second full match is correct, but the first one doesn't make a lot of sense. So ABCD, XYZ, ABCD, XYZ, ABCD. And we're looking for BCD. Okay, so it's still finding 3. The indices are a tiny little bit wonky though. Or are they? Well, this is the painful decision of, is it good enough or should we keep investigating? It is legitimately finding three matches. So let's break the first one. Well, it looks like it's working. So it might be that we can consider this to be good enough and just move on with our lives. And moving on means moving on to the next exercise. Oops. And let me close some files. Yes. Okay, now this was tough. This was a lot of work. We're almost there. Oh, drawing. I'm going to take all of these and consider them a sort of bigger exercise. Okay, so we need to draw a line of asterisks of length n, then a square of asterisks of size n, a triangle of asterisks of length n, a pyramid of asterisks of height n, and a circle of asterisks of radius n divided by 2. The last one is very tough. Okay, so let's start by getting n. What is the size of the image? Okay, now we are basically going to go through the pixels of a sort of imaginary monitor, a sort of virtual monitor that only exists in a variable. And then we're going to assemble a string, which we're going to call the figure or the picture, and we're going to assemble it. Okay, so we start with rows. We go through the rows. And there are how many rows? Well, n, as you can imagine. Why is it unhappy? Oh, of course. Okay, once again, without any input validation, which I really should be doing, I will be just converting the number, the string that we get into a number. Now, for each row, for each column, and then, well, after a row, of course we know that the figure has to get /n. Oh, but. So, let's now generalize a little bit. Let's not automatically assume we're drawing a square, otherwise we cannot really do the line. Okay, so we have a width and a height. Okay, so the rows are, how many rows do we have? Well, until the height, and how many columns until the width. And here, we can simply say that the figure gets an extra asterisk. This construction makes it possible for me to simply say that if the height is 1, I'm drawing a degenerate square or a degenerate rectangle, which is the row. There you go. And by saying that the height is n, there's our square. Well, obviously, these are characters in a terminal, so they are taller than they are wide. Okay. The first two, we got them easily out of the way. Now we're going to build a triangle. Okay. So for a triangle, okay, we could say that we need all the rows. For the columns, we could stop at the value of the row. And there's the triangle. That was easy, because let's say row 3, we only want to have 3 columns. Row 4, we want to have 4 columns, and so on. Yeah, that's very easy. This code we're going to need it later, so I'm just going to comment it away. So the triangle was also easy. The pyramid. Okay, the pyramid is interesting because the pyramid requires a little bit of thought. So let's start by first of all, the pyramid has only odd numbers of asterisks, but there's also spaces before every row, and the number of spaces, they require knowing how many rows do we actually need. So the first number of spaces here is 2, then the number of spaces decreases every time, and the number of asterisks increases by 2. So the number of spaces decreases by 1, the number of asterisks decreases by 2. Let's add another row. This always help. Okay, so here we have 1, 2, 3, 4 rows, 1, 2, 3 spaces. It kind of makes sense actually that the spaces are the number of rows minus 1, because every row will remove 1 space until the last one has no spaces anymore. So, okay. So the number of spaces will be n minus 1, so the number of rows minus 1. the number of stars or asterisks that will start at 1. Now, while num spaces is greater or equal than 0, now we can simply draw a row where we have num spaces and num stars, and after this we say that the num stars are incremented by 2 and the number of spaces is decremented by 1. And now we can just draw a row with all the columns. This bit we can copy. Obviously it's not the width here, but it's the number of, well, first the number of spaces, followed by the number of stars. Okay, let's run it. Let's see how lucky we got. We did not get lucky. Oh, well, or maybe we did, just the wrong character. Ooh, almost. Oh, it's smaller equal. Haha, copying and pasting code is bad, because these things happen all the time. Whenever you copy and paste code, you will not think about it. It's also my pet peeve against the lovers of ChatGPT styled programming. Copying and pasting code is one of the most dangerous activities in the life of a software developer. But anyway, I digress. Good, looks like it's working. Let's try for the 7. Okay, still a pyramid. Let's try for the 2. Also a pyramid. Try for 3. Also a pyramid. Okay, great. It looks like it's working. Now the circle. Ooh, the circle is really tough. And why is it really tough? Well, because it's very hard to, well, I mean, it's not impossible, but it's a lot of mathematics that I am personally not good with, to find out if you're trying to build a row, to know precisely how many pixels, so how many spaces you have, how many stars, and then how many spaces, because that is how you would build a circle with the same logic of the pyramid. So we're going to try something else. So if we want to have a circle of asterisks that's centered about the middle of the picture, we could say that the middle of, well, it's a square, so the middle is just going to be n divided by 2, right? Now we can simply check the distance, which is the square root of the coordinates xy minus the middle squared. Okay, so we can simply check the distance between the current pixel and the center, and if the distance is smaller or equal than the radius, which is also n divided by 2, then we turn the pixel on, otherwise we keep it off. So if, well, actually, const distance math.sqrt, so the square root. Okay, so the x and the y are the row and the columns. Now I'm going to change the name of these variables. I will call this y, and I'm going to call this x. So the names of variables, especially when dealing with a domain like this, which is, let's say, mathematically oriented, should be aligned with the names that you would typically find in the literature or in whatever domain. So it's all fun and games to invent your own names for variables until you make it impossible for the actual domain experts to understand what the heck your code is about. So in this case, we have y and x because our domain has y and x. Okay, so now we say x minus middle, and then this has to be squared, plus y minus middle, and this also has to be squared. Okay, so this is the distance from center. And now we say that if the distance from center is smaller or equal than the radius, then we turn the pixel on, otherwise we keep it off. Probably going to need, well, let's start with 15. Okay. Well, as you can imagine, using asterisks is not exactly the most precise way. Oh, and odd is better, of course. It's not exactly the most precise way, you know, of plotting. You need a lot of pixels. Here you see why in life we need pixels, why monitors with bigger pixels are important. And this is we're now simulating a sort of monitor with the resolution. The last one was of 21 by 21, so it's not a lot. With 5, with 5 it's still a square. With 7, okay, with 7 it's almost recognizably a circle. Oh, 9 looks uglier than 7, but you know, it still works. Okay, I can imagine these exercises are very tough, and probably your experience with all of these exercises will look a lot like my own experience with the prefix bit. It's okay to be lost. When you're lost, remember, validate your hypothesis like I did. Decompose your program, print intermediate values, find out all the little bits and pieces of your logic and just think about them until you properly understand the problem that you're trying to solve and you properly understand the bug that's actually, you know, taking place in your code. And in no time, you will see, you will win against, you will overcome the challenge and win against the problem. Thank you very much for listening. I hope you've enjoyed these exercises. I do believe the exercises to be the most important part of learning how to program. The best of luck with your study, and until next time.